All right, so we're going to learn about momentum and impulse today. So momentum is very simply, the definition is product of the mass of an object times its velocity. And that's the definition, mass times velocity. It's a measure of the quantity of motion an object has. So how much motion does an object have? The symbol we're going to use is a P. Again, the formula is the definition, momentum, mass times velocity. You want to make sure mass is in kilograms. Velocity, of course, meters per second. So we have momentum equals mass times velocity. Our units don't have a really special name. It's just kilograms meters per second. So as we look at momentum and its measure of the quantity of motion, something that is moving a lot would have a lot of momentum. If something is moving fast, it would have a lot of momentum. If something has a lot of mass and is moving, it has a lot of momentum. Now, notice what happens if velocity would be 0. So if you're at rest, your momentum is 0. So if you're not moving, you cannot have any momentum. Objects at rest have 0 momentum. If you are moving, then you will have momentum. So a fast-moving bullet and a slow-moving car can have the same momentum. Okay, mass times velocity, mass times velocity. They will have the same quantity of motion. They will have the same momentum. I like to think of it as anything that has a lot of momentum as being hard to stop. Now, when it comes to stopping, there are a lot of factors that come into play, but this just kind of helps you understand what momentum is. If you have a lot of momentum, like a train, it's going to be hard to stop. A fast-moving bullet would be hard to stop as well. Okay, so it doesn't have a lot of mass, but it has a high velocity. So both can have the same momentum. So what happens if you want to change momentum? Well, we call that an impulse. It's what you use to change momentum. Don't forget, triangle means change in. And our formula for impulse is force times time. Okay, so impulse equals force times time. So impulse is represented by a capital I, force times the change in time, or in our case, we'll just use time, of course. To change momentum takes an impulse. So momentum is mass times change in velocity equals force times time. And so now we have momentum equals force times time. So mass times final velocity minus starting velocity equals force times time. So this will be our basic equation for the next couple days. And I will basically have to give you all variables but one, and then you solve for it. So as you see, I would recommend that you write down what's given in the problem and then identify what you're solving for, and then it just becomes like a plug and chug. Don't make this equation harder than it is. So if you want to change momentum, it takes an impulse, force times time. So what's a practical application of this? Well, it's called the physics of cushioning. Increasing the time of impact, thereby decreasing the force of impact. So we know if there's a moving object, it will have momentum. If you want to stop it, it's going to take an impulse. So what's the best way to stop something? Well, you want to cushion, you want to absorb the impact, you want to have a gradual impact, you want to have give, you want to have a shock absorber, easy for me to say. All of these utilize decreasing momentum over a long period of time. What does that do? That minimizes your force, minimizes the force. Okay, because force times time is going to equal, let me change the color here, is going to equal momentum, right? So if you want to decrease momentum, it's going to take a force and a time. Well, cushioning increases the time, therefore, or thereby creating a small force. So the physics of cushioning. Let's look at a couple of examples here. So here's some examples. So why is the dashboard padded? Well, that's going to, if you hit the dashboard, that padding will give, increasing the time of contact thereby decreasing the force. Airbags increase the time of contact, decrease the force you feel. Baseball, catching with a glove versus barehanded. The glove has padding on it, so increasing the time of contact, decreasing the force that you feel. If you jump off a table, why do you bend your legs? To increase the time of contact. Why is the gym floor wooden, not concrete? Wood gives, increasing time of contact, decreasing force. Now, I am going to do a couple of demos in class that hopefully will help make some of this clear. But all of these here increase the time of contact, decreasing the force you feel. Decreasing the force you feel. So a nice little summary here. Force is applied to change motion of an object, right? F equals ma. F equals ma. That force changes the motion of an object, causing it to accelerate. Impulse, best way to think of that, is applied to change the momentum of an object. Impulse is applied to change the momentum of an object. And of course, our equation there, force times time equals impulse. So notice the difference in our equations here. Force is mass times acceleration. Impulse is force times time. Okay, force changes the acceleration. Impulse will change the momentum. Now, both of these, we learn them separately, but as with everything in physics, it all happens together. So everything we've learned from day one until the end of the year, all of these things occur simultaneously. We learn them individually to help make it hopefully make more sense, but understand all these things happen at the same time. Newton's 3 laws, vector calculations, force, impulse, momentum. Next, we're going to talk about energy, work, power. All of these are occurring simultaneously. Okay, so let's look at a sample problem. Again, I would list what we know. Now we do have A and B here, so I'll go through both, but kind of write them together, if you will. So we know our mass is 75 kilograms. The car is traveling 18 meters per second, so that's my starting velocity. It comes to rest, so my final velocity is 0. And then for part A, our time is 0.102 seconds because we have an airbag. And we want to know what is our force. Okay. Well, we know momentum equals impulse. Momentum is mass times change in velocity. And we know impulse is force times our time. So 75 times 0 minus 18 equals force we don't know times 1.02. So as you can see here, 0 minus 18 is going to give us a negative number, which is fine. Momentum, impulse can all be negative. It just tells you the direction of the force in this case, if you will. All right, so 75 times negative 18 is negative 1350. Force times 0.102 seconds. Now we're going to divide. And of course, I'm running out of room here. But 1350 divided by 0.102 is 13,000 newtons. Now, if we compare that to no airbag, so let's see what that does. 75, 0 minus 18 equals F we don't know, and our time is 0.04. Notice this is only a difference of 600ths of a second. And notice what this will do. So I don't have a lot of room, I'm going to kind of just talk, but 75 times negative 18, again, 1,350. But now we're going to divide by 0.04, and now we get 34,000 newtons. So notice just a 600th of a second off. You go from 13,000 newtons to 34,000 newtons. Physics of cushioning, the airbag, so important. So that's the physics of cushioning, but let's just talk about, what if you want to maximize your momentum? How are you supposed to swing a baseball bat? Well, you swing as hard as you can and you follow through, right? Golf club, same thing. You swing as hard as you can. Okay? So what you're trying to do is you're both trying to increase force and time. So you hit the object as hard and as long as possible, you follow through. And what that does is that increases your time and increases your force, which increases your momentum. Because you're trying to change the motion of the ball, baseball or golf ball. So you follow through. Increased time of contact, that increases the force, that increases impulse, which increases the momentum. So let's look at our last important concept and then do just a couple more sample problems here. What about if something bounces? Okay. Well, if something bounces, the impulse will be much higher because the object must be stopped and then thrown back again. So you're completely changing the motion of the object, like making it do a 180. All right, so impulse is much higher. So if we look at the math here, how much force must be applied to a 1 kilogram ball traveling 20 meters per second to stop it in 2 seconds? Okay, so mass is 1, Vf is 0, Vi is 20, and our time is 2 seconds. Okay, so we know 1 kilogram times 0 minus 20 is going to equal force times 2. It's our time, right? So negative 20 equals force times 2. Divide by 2, we get negative 10 newtons. So if you hit and stop, the force you feel is negative 10. Well, let's compare that to if we bounce. Now, in this case, my final velocity will be negative 20. My initial velocity is 20 because we bounce backwards at 20. So we're going to say that it's negative 20. So notice how that changes our equation. So mass times final velocity minus initial velocity equals force times our 2 seconds again. So negative 20 minus 20, so now we have negative 40 equals force times 2, divide by 2, and now you have negative 20. Okay, bouncing requires more force. So if something hits you, okay, you want it to hit and stop. If it bounces off of you, it's going to hurt a lot more. It's going to generate twice the force that you feel. So if you get hit with a baseball, you want it to hit and stop. Yes, that hurts, but it hurts a lot less than getting hit and then having it bounce off 20 feet. That would hurt a lot more. Something falls on your head. You want it to hit and stop. You don't want it to hit and bounce off your head. You would feel twice the force in that case. Okay? Well, it's not always twice. I'm just using that as an example. You would feel more force if it bounces. All right, so momentum, mass times velocity, impulse, force times time. If you want to change momentum, it requires an impulse. Okay? All right, so you have some sample problems to try. Let me know if I can help. Talk to you guys later.